So today we're going to be talking about 14.3, which is multiplying polynomials by a monomial. Remember, monomials, one term. Okay, it's made up of either constants and variables or a combination of the two. We can't have variables in the denominator. We also can't have negative powers. Okay, and we can't have fractions for a power. Our essential question of the day. How do you multiply polynomials by monomials? Well, quite simple, and I'll definitely get into that, but all we do is multiply coefficients and add exponents, okay, to multiply monomials. Use the what? Distributive property. We're going to talk about that a little bit more to multiply a polynomial by a monomial. Okay, so let's talk about this word distribute for our vocab, okay? Distribute, you already know. It's basically we're multiplying, all right? So in regards to multiplying what, though? We're going to take a constant or a variable or a combination of the two, right? And we're going to multiply each term in the parentheses. So terms are separated by what? Plus and minus signs. So if I had 4, 3, 2, and I had a 5 out here, notice what's happening. I can distribute into all three terms, and that gives me how many problems? 3, because I have 3 arrows, and all the arrows mean what? Multiplication. So this says 5 times 4 plus 5 times 3 minus 5 times 2. And then you can literally look at this and say, okay, 5 times 4 is what? 20. 5 times 3 is what? 15. 5 times 2 is what? 10. And then we just simply add or subtract, and that's going to go, since they're on the same level, from left to right. So 20 plus the 15, that gets me to 35. 35 minus the 10 is back to 25. Now, remember the rules of PEMDAS. PEMDAS says do what? Do what's in the parentheses first. Can I add and subtract constants? Yes, I could have. So watch this. 4 plus 3 is what? 7. 7 minus 2 is what? 5. Right? So now I really have 5 times 5. And what's 5 times 5? 25. So as you can see, we can distribute this in, or we could do what's in the parentheses first, and either way we'll still come out with the same answer. Okay? Now, we're going to get into this a little bit later, but remember the combinations. I can do a constant into the parentheses. I could do a variable into the parentheses, or I could do a combination of the two into the parentheses. Okay? And it doesn't matter if it's positive or negative. Either way, what is one of the techniques that we like to do? We like to draw arrows. Why? The arrows focus us. The arrows tell me to multiply. So for every arrow, I have another equation that I can actually do. All right? Okay, multiplying variables with powers. We have to talk about this because when we distribute, sometimes we're going to have x times x, y times y, or even x times a y. So how do we handle that? Well, first, I'm going to back up and say, what happens when we add or subtract? Well, if I have x plus x, I know they're the same family, so I can combine them because it's the same family, x, and they have the same power. So all I do is what? I add the coefficients. The variable and the power, they don't change. So I get 2x to the first power. All right. What about subtraction? If I had 2x minus x, what does that say to do? Well, x's are in the same family because they're the same x and they have the same power. The coefficients are 2 and 1. So I just subtract the coefficients. 2 minus 1 is 1, and I keep the x exactly the way it is. But that's not true when it comes to multiplying, okay? when I multiply or divide, I'm actually going to start doing some different things. If I multiply, I am going to add the coefficients. Add the powers. Sorry about that. I'm going to add the powers. If I divide, what am I going to do? I'm going to subtract the powers. Okay? So these are two big, these concepts are a little bit different. So let's say that I take the same thing, x to the first power. This time I'm going to multiply it by x to the first power. Remember, I could show that a couple of different ways. X times x. I can show, even with brackets, this all means multiplication. I could even, which wouldn't look too well, put an x here like that, and then say multiply. So those are all forms of just saying the same exact thing. X times x. Well, as you can see, we now have to look at the powers. So there's how many powers up here? 1 plus 1. So my answer is what? X squared. Same thing would happen down here. This is x squared, this is also x squared, and this is also x squared. Okay? So that's very, very important. We need to be able to say x to the third times x to the fourth and get 3 plus 4, which is equal to what? X to the seventh. What about x negative 1 times x to the fifth? Same thing. Put negative 1 plus 5. And what do you get? 4. So x to the fourth. You are always just going to add the powers. Does that make sense? Now, let's add in a coefficient. 2x to the fifth times 3x to the fourth. What do I do first? I multiply the coefficients. So 2 times 3 is 6. Now I keep the family of x and I add the powers. So I get 6x to the ninth. Okay, let's change up these variables. Let's say it's b. Let's put 10b to the negative third times 4b to the sixth. So what do we get? Well, 10 times 4 is 40. B will be negative 3 plus 6. And what do we get? 40b to the third. Does that make sense? Cool. So what about if we divide? I like just going through this so you actually have the information, even though we're not going to do this chapter. If I'm dividing, it's the same thing. So if I have x to the second divided by x to the first, we are going to take what's on the top in the numerator and subtract what's in the denominator. So I have a power of 2 and a power of 1. So 2 minus 1 is equal to what? You got it, x to the first. And that's pretty plain to see. If I look at this in another way, I can say that's x times x over x. And we know x divided by x is just 1. And how many x's are left? 1. All right, so what about x to the fifth divided by x to the third? What do you get? X to the fifth minus 3. And what is 5 minus 3? 2. Good. Again, I can show you 1, 2, 3, 4, 5. There's 5 x's up top. And how many are down below? 3. That's 1, that's 1, that's 1. How many are left? 2. Okay? So when you divide, all you do is subtract, which brings in another rule of math. If I have a negative exponent, I cannot leave that in my answer. So if I have negative 2 for x to the negative 2 power, I cannot leave that. So put it in a fraction. And then I am going to put it in the, I call it the basement, but I'm going to put it in the denominator, okay? So 1 goes up top because there's a 1 right there. X squared comes down below and becomes positive. I could get into the reasons why this happens. I'm just going to tell you straightforward what to do, and then you'll be able to do it. So let's say the reverse is true. Let's say that it was 1x to the negative third. Well, how do I get that power to be positive? I put it in the numerator. So remember, there's a 1 right here. So this is equal to 1, and then I put x to the third. Okay? And I can get into this a more complicated deal. I just want you to know you can't leave negative powers in your answer. So make sure that you're able to flip them so you're able to get a positive power. Okay, so here we go. We're just going to multiply by a constant into some parentheses, which is a polynomial. Right here we have a binomial, okay? Pretty simple and straightforward. It still follows our 4 steps, which is simplify slash what? Simply, not simply. We want to simplify, okay? Simplify, and we want to slash combine like terms, okay? So now, with that being said, simplify, what are the checkpoints? We got PEMDAS, we have distribute, we have remove fractions, and we have factoring. That's how you simplify. You got PEMDAS, distribute, remove fractions, and factor. That's how you simplify any problem right off the start, okay? So now, what are we going to do? Anything to do with PEMDAS? Well, there's something in the parentheses, but nothing that I can actually add or subtract. So nothing to do with PEMDAS. Can I distribute? Yes. What am I going to distribute? This 6 into both terms. I have 2 terms here. What do the arrows mean? They mean multiply. So therefore, 6 times negative 4b. Okay? And then I'm going to add what? 6 times a 3g. So let's just do it. 6 times a negative 4b is a positive, and a negative is a negative. 6 times 4 is 24, and I'm left with a b. Plus 6 times 3 is what? 18g. So my new binomial, okay, is going to be negative 24b plus 18g. Okay, so our second example now. I have a different kind of polynomial. How many terms do I have? I have 1, 2, 3, 4, 5. Does that stop us from distributing in? No. So simplify slash combine like terms. What am I going to do? I'm going to distribute. What am I distributing? A negative 20 into each of these terms. So how many problems do I have? I have 1, 2, 3, 4, 5. So here we go. Negative 20 times C. 20. Notice I put the negative here. I'm just following along. 20 times 3D. Here's a positive. 20 times 4M. Negative. 20 times 8S. 20 times 9Z. How many problems do I have here? 1, 2, 3, 4, 5. All of these I have to simplify just by doing the PEMDAS, okay? So I get negative 20 times C. Oh, that's simple. Negative 20C. Minus, watch this, 20 times 3 is what? 60. So I get minus 60D. 20 times 4 is 80. So I get plus 80M. 20 times 8 is 160. So I get 100 and minus 160S. 20 times 9 is 180, so plus 180Z. Now, this is a C family, D family, M family, S family, Z family. There's nothing I can simplify, and it's all in alphabetical order, so that is your final answer. Your polynomial has what? How many terms? 5 terms. What's the highest degree? You're right, 1. So it's a first degree. So let's multiply by a positive monomial, which we've already done. We did it with a constant. This time I'm going to put a variable alongside of it, so now we have a combination. Does anything change? No. We're still going to simplify it by distributing. How many arrows do I have? 2, because it's a binomial. Okay, so that means multiply. So now I have 6x times a negative 4x. And then I'm going to add a 6x times a 3y. Okay, here we go. What is 6 times 4? Well, 6 times a negative 4, that is, negative 24. Oh, look at this. This is x times x. Here's a power of 1. Here's a power of 1. What do we do with that? We add them together. So I get negative 24x squared. Okay, plus 6 times 3. Always do the coefficients first. So 6 times 3 is 18. What's x times y? Exactly what it says, x times y. Now, we don't put the dot there because it's just redundant. So we leave it alone. So this is just plus 18x times y. That's exactly what that means. So this says negative 24 times x squared plus 18 times x times y. Okay, so our second equation, our second example of that, we have negative 20x, and then we're going to multiply it in. So here we go. We're going to distribute this in. Notice, really didn't change the problems. All I did was add a little something to it, just so you can make sure that you're comfortable doing it no matter how big the numbers are, what the variables are, and be able to go from there. So you should be able to write this down. All right, so negative 20x times what? C. Then what are we going to add or subtract? You got it. Subtract it. So we got negative 20x times 3d. Add or subtract now? We're going to add. So we get negative 20x times 4m. Add or subtract? We're going to subtract negative 20x times 8s. Add or subtract? Yep, you got it. Add what? Negative 20x times 9z. All right, so now let's just do it. Here we go. Negative 20 times c. All right, negative 20x c. That says x times c. That's how simple that is, okay? All right, so negative 20 times 3 is negative 60. But there's a negative out here. What's out there? A negative 1, correct? So we could distribute that in, or just realize that a negative times a negative is a positive. So now I get what? That's negative 60. Negative 60 times this negative 1 is positive 60. And then I have x times d. All right, here we go. Negative 20 times 4. Yep, negative 80. This is a positive 1, so I keep the negative 80, okay? And then x times m. Now, negative 20 times 8 is negative 160. But what's out in front? A negative 1. So if we distribute that in, a negative and a negative is a positive. So I get 160 x times s. Then I get negative 20 times 9, that's negative 180, is a positive 1. So I keep the negative 180, x times z. Now, we can't leave it like this. Why? Because the rules say that we should put everything in alphabetical order and from greatest power all the way down. Well, all the powers are 1, so we're good there. So this really should write negative 20 c times x plus 60 d times x minus 80 m times x plus 160 s times x minus 180 x times z. See how I just put that in alphabetical order? There we go. So let's multiply by a negative monomial. All right. We already did that in one of them up top, but we have a few things here. I just want to reiterate how we're doing negatives and how we treat them. I'm going to show you a little bit different way in the sense of just separating them and making sure that you understand that these signs must travel with them. Okay, so one, we're going to distribute. Okay, so we got this. Arrows just show that I'm multiplying the binomial by negative 6y. So I have negative 6y, and what am I going to do? Multiply it by what? A negative 4x. Then I'm going to do what? I'm going to add. Add what? Negative 6y times 3y. Can I simplify those? Yes, I can. How do I do that? When I multiply the coefficients first. So a negative and a negative is a positive. Okay? So if I have a positive there, I get positive 24. And then I multiply the y and the x. So I'm just going to go ahead and switch it right now. I'm going to put x and y. Okay? Now, where is this? It's a positive 1. If I distribute a positive 1 in here, does it change anything inside of those parentheses? No, because anything times 1 is itself. So what this says is negative 6 times 3. A negative and a positive is a what? Negative. So I get negative 18. And y times y says 1 plus 1. Because when I multiplied a same family member, immediate family member, or extended, I just add the powers. So I get 24xy minus 18y squared. Does that make sense? There's nothing else for me to do because this is not in the same family. I have an x and a y. I only have a y. They must be exactly the same in order for me to add or subtract. Okay? And these are not the same. Not only do they have to be the same variable, but they also have the same what? Powers. And this power is 1, this power is 1. Okay? So I am done. This is the final answer. Okay, so let's multiply by a negative, but this time I even put an x and a y. Okay? So remember, real simple, we draw these arrows in here. Why? All they do is just make sure that I understand that I'm multiplying, distributing into every term in that in the parentheses. Okay, so step number 1, we are going to distribute. Okay, so here we go. I got negative 20 xy times what? Cx. Then what am I going to do? I'm going to subtract what? Negative 20 xy times what? 3d. Then what am I going to do? Add what? Negative 20 xy times 4x. Then what? Subtract. Subtract what? Negative 20 xy times 8y. And then the last thing that we're going to do is add. Add what? Negative 20 xy times 9z. Okay, so last time I didn't distribute these negatives in, or the positive ones, but this time I am. Okay, I want to make sure you understand that what's out here. There's a positive 1 there. Here's a negative 1. Here's a positive 1. Here's a negative 1. Here's a positive 1. So what can we do with those? Yes, we could distribute those in, but positive ones don't change anything. Okay, because anything times 1 is itself. So I just get this negative 20. What's this coefficient? 1. So I get negative 20. And now watch this. xy times cx. Well, I have 2 family members here. So what should I do to them? Yes, I should add them. And what am I adding? The powers. So I get what? Negative 20x squared. y, c. Okay, and now I'm going to even put it in alphabetical order. So I get c first, x squared, y. Does that make sense? And I really broke that down so you could see it, just so you're not just going, oh my goodness, I don't know what he just did there. All right. So this one has a negative 1. So if I distribute a negative 1, things change. A negative and a negative is a what? Positive. So I get a positive xy. But this positive 3D is really what? Negative 3D. And I am going to multiply those two things together. So 20 times a negative 3 is what? Negative 60. And then I get x, y, d. So since these are all different variables, really don't have to do anything but put them in order. So I get negative 60, d comes first, x, y. Okay? So now, here we go. This is a positive 1. If I put a positive 1 in there, does it change anything? No. So negative 20 times 4 is what? You got it? Negative 80. Because a positive times a negative is a negative. And then I just get x, y. Here's another x. So what do I have to do with these x's? They have powers of 1. I need to add them. And what do I get? Negative 80 x squared y. Okay? Then right here, I have a negative 1. If I distribute that in, a negative and a negative makes it a what? Positive. A negative and a positive makes it a negative. So I'm really doing 20 xy times negative 8y. So here we go. 20 times a negative, well, a positive times a negative is a negative. I get 20 times 8 is 160. And then I get x, y, and y. Oh, look at that. I have 2 y's. So what am I going to do with that? You got it. I'm going to add those powers. So I get negative 160 x, y squared. Then here's a positive 1 distributed in. Does anything change? Nope. So negative 20 times 9. What do you get? You get a negative 180. And then you get x, y, z. Anything to do there? Nope. So just bring it down. Negative 80, x, y, z. My final answer is right here. Negative 20 cx squared y minus 60 dxy minus 80 x squared y minus 160 xy squared minus 180 xyz.